Chapter 3, Section 1 involves exponential notation and simplifying exponential expressions. Exponential notation is a simpler way to write longer equations. Like, for example, 2 times 2 times 2 is the same thing as 2 to the third power. But where do we get these numbers from? The 2 in our answer is called the base. And the 3 is called the power. And this expression is read 2 to the third power. Okay, but how do we get our power and how do we get our base? The base is from the actual number or component multiplied throughout the problem. So in this problem, it is a 2. And the power is the number of times that component is multiplied by itself. So, in the next example, we have x times x times x times x. Our base would be x, because that is component multiplied throughout. But if we have x multiplied by itself 4 times, our power would be 4. This would be read as x to the 4th power. If we have the example 5y times 5y times 5y, our base in our problem would be the 5y, because that is the component multiplied throughout the problem. And since it is multiplied by itself 3 times, our power would be 3. But we need to make sure to include the parentheses to include the 5y as all being raised to the third power. And this would be read as 5y to the third power. Now, what happens if we have a problem like, instead of having a times a times a times a, which from what we know before, we take the base, which is a, and raise it to the power that is multiplied by. So since we have 4 a's here, it would be raised to the 4th power. But what if we have a problem like a to the 4th multiplying by a to the 2nd? In this situation, since these exponents are multiplied by each other, we add the exponents. So here this would be the same as adding the exponents 4 plus 2, which gives us a to the 6th, because a to the 4th and a to the 2nd is the same as a times a times a times a multiplied by a times a. So since we have 6 a's here, this would ultimately be the same as a raised to the 6th power, which makes these two statements valid. So we just need to remember the when exponents are multiplied by each other, that we can add their number of exponents. So in another example, if we have x to the 3rd power multiplied by x to the 1st power, we can remember, since these are multiplied by each other, that we can add the number of exponents. We have 3 plus 1 will give us x to the 4th. In another example, if we have 2a as our base raised to the 3rd power multiplied by 2a raised to the 4th power, again, since these are both multiplied by each other, we take the base and we add the exponents, 3 plus 4, which will give us 2a raised to the 7th power, because 3 plus 4 is 7. In more examples, we have 10 to the 7th power multiplied by 10 to the 11th power. This is the same as having 10 raised to the 7 plus 11th power, which 7 plus 11 is 18. So we have 10 to the 18th power. If we have a problem like 2 to the x, or 2 times x to the third power multiplied by 3 times x to the second power, this would be the same as writing 2 times 3 multiplied by x to the third times x to the second. We're allowed to do this because the numbers, the coefficients in front of the x components have nothing to do with the exponents. It can be multiplied in front of it as the x's can be multiplied by each other. So it's a way to simplify the problem. So from this, this is the same thing. So this is the same thing as having 2 times 3, which is equal to 6, multiplied by, if we write all this out, x times x, x, x times x, which is the same as 6 times the base, which is x, raised to the 5th power, which we get the 5 from having 6 times x to the third plus 2. And that's where we get our x to the 5th power. In a similar example, if we have 3 times y to the 4th multiplied by 1 times y to the 5th, this would be the same as writing 3 times 1 multiplied by y to the 4th times y to the 5th, which would be equal to 3 times y to the 4 plus 5. We write the 4 plus 5 again because the y's are multiplying by each other, and we add the exponents. And from this we get it is equal to y, or 3 times y to the 9th. When we divide exponents, like x to the 3 divided by x to the second, it is the same thing as subtracting the exponents. So when we multiply, we add the exponents, but when we divide, we subtract. So in here we have 3 minus 2, because we always take the top minus the bottom. So x to the 3 minus 2 just leaves us with x to the 1, which is the same thing as just x. So again, another example, if we have y to the 4th divided by y to the second is equal to y to the exponent of the numerator, which is 4, minus 2, is equal to y to the second power. When we have a factor with an exponent raised to an exponent, like for example, x to the third, all raised to the second, it's the same thing as multiplying those exponents. So then we have x times 3, x raised to the 3 times 2, which would give us x to the 6th. So again, when we have exponents that are raised to another exponent, so we have y to the 4th raised to the 3, we multiply those exponents. So y to the 4 times 3 will give us y to the 12th power. The next example is when we have two different bases. So when we have x times y, and this is raised to a number. This has a distributive property that is like, we take x we raise the exponent of that number to both of the components. So then we have x to the third times x, or y to the third. So in another example, if we have 4x all raised to the second power, then we take that, we multiply, or raise both of those to the second power, so we have the 4 raised to the second multiplied by x raised to the second. This is very similar to the distributive, or the quotient power rule, which takes two different numbers, or bases if you will, and they are raised to the same exponent. So again, this number is distributed to both. So this is the same as x squared over y squared. Now if we have 2 over x raised to the third power, this is the same as 2 to the third divided by x to the third. When we have expressions with numbers, we want to make sure that we simplify them to the very furthest. So when we have 2 to the third, we can make that 8 over x to the third. Same thing up here at this last example. Two previous examples, if we have 4 to the second power, we can make that 16 times x squared. And then that would be our final solution.